Hi, welcome to Hunt Utilities Group. We're really proud to have you here so you can see and understand a little bit more of what we're doing. At this point, Hunt Utilities Group is focusing in on energy alternatives. We're looking at sustainable living, which is we want to be able to use what we grow and grow what we use concept. We were looking at roots and wings because it's an old concept.
These roots are made, sculpted out of the same plaster material that's on the walls.
One day our artist was actually working on the window, and he made something that looks a lot like roots, and it's gorgeous.
Mm-hmm.
And I walked in and I was just marveling at it.
We feel that we're building the roots here for a new way of trying to live, which is actually an ancient way, going back to very old paths of living closer to the earth. We also want to try using some of the old technologies, which is the cob and the straw bale, and create these kind of neat houses to live in.
Cob is one of the oldest building materials ever used. Cob is a mixture of clay, straw, sand, and water. It can be used both in the dynamics of preserving thermal energy as well as have great artistic feel to it.
If we want to show the world that building things out of straw and mud can actually be gorgeous.
The works that you see here were created by Peter Anderson. He demonstrated how elegant cob can be made. Our campus is probably different from any campus that you'll visit, at least in the state of Minnesota, where we're looking at energy, we're looking at environmental housing, we're looking at being able to live and sustain our lifestyle close to the earth, but we're also an education facility, we're a business incubator. And the design behind this is to try and bring people to our campus who have a shared interest. Our business incubation, for example, is specifically set up so that those who are interested in solar, wind, thermal, or even food production in an organic manner would have a place that they could come to and work with us and learn from us.
We want to prove to the industry and the rest of the world how it works. And of course, we want to know that ourselves. So we've installed hundreds of sensors, moisture sensors and temperature sensors.
This building is actually a research lab. Every aspect of this building is something that we're studying. We're studying the performance of the cob, the performance of the straw. We have hundreds of monitors throughout the entire building monitoring airflow, air temperature, humidity. And the key reason is that we want to be able to build homes that are highly efficient, but also very elegant. And so in the environment that we're in right now, we have the ability to track temperatures 24 hours a day, 7 days a week, and we can access that and control it on the web.
I think a house should hate itself. It shouldn't be a huge sink to suck up all your dollars.
This building is designed in such a way that we've got 3 foot by 3 foot by 8 foot straw bale structure. So it gives us an R value of 100. The ceiling has an R value of 100. In the standard home, you generally have 6 to 12 inch walls and an R value of maybe 20 to 30. But the way that we designed the building, the awning sets out 7 feet.
The overhang on the south side of the building is very important. In the summer, when the sun is high and overhead, it blocks the sun from the windows. In the summer, or in the winter, when the sun is low and to the south, it shines in all the windows, allowing us to collect as much heat as possible.
So we can capture optimum solar energy, passive solar energy, in the wintertime, and yet in the summer, the shade casts perfectly right at the foot of the building. So the design of it was very deliberate to capture every bit of solar that we can. The other element that we did that I think is very important is we created a heat sink. The heat sink was designed before we put up any of the walls, and it's trenched air that takes the air from the top of the building, brings it down into the ground, so we are capturing all of the warm air that circulates around.
The way the building is designed, warm air heated by the bodies, the electricity used in the building, and the sun coming in the windows rises up to the point up at the top. What we do then is we take the hot air, pull it off the top, down along the windows, and under the floor We have a series of air channels under the floor, 2 feet down, and that allows us to heat up not only the concrete on the floor, but the earth underneath that to a height of 2 feet or 4 feet, depending on how much warmth there is. And that allows us to store the heat when the sun shines and make use of it when it's a cloudy day.
We put a perimeter of 8 feet of foam around the outside so that we wouldn't have any frost creep. And that, we found last winter, worked very well. Part of our campus mission is to find different ways that we're able to sustain ourselves without being on the grid, and yet desire to be on the grid in part so that we can be selling power back to utilities rather than just taking it from utilities. So in an environment where you've got zero net consumption, you want to be on the grid. You want to be part of that energy flow, but you want to be able to go both ways. You want to draw energy when you need to, but also sell energy back to the utility when it needs it, when you have the capacity.
We want to find ways of being able to train people to use these kind of things that we come up with, and that becomes the educational aspect of it.
That without advertising or really having anything to sell, we have buses of people coming in, senior citizens, high school students, who just want to learn what we're doing, see what we're doing, experience the feel of cob in their hand, and have an opportunity to understand how this might impact, people's lives going forward.
It's important for us to create a destination point here where all of the people that have questions can come. They can see these types of projects in place. They can see solar being used. They can see the wind mills if we get them in place. They can see cob houses. They can get the feel of them, because without feeling it and seeing it, you don't really understand the difference. And that's what we want to bring about, is that you can actually see it, feel it, learn about the technologies, learn about the concepts, and actually begin to put them into use yourself.